It's so hot right now. I'm so thirsty. Let's make kusira water. So sweet. I wonder how many sugar in this bottle. How can I measure it? Let's find a video about this topic in my teacher's channel.
Hello and Assalamualaikum everyone. Welcome to my channel to learn chemistry with fun with me, Miss Auni. At the end of the lesson, students should be able to first conceptualize relative atomic mass and relative molecular mass based on the carbon-12 scale. Second, calculate relative molecular mass and relative formula mass. Student, have you ever tried to measure 1 grain of sugar? Can you count or measure it, student?
No!
Yes, correct, student. Basically, we cannot count only 1 grain of sugar because the size is too small. In chemistry, the smallest thing is known as atom. Hence, there is no weighing machine that can give the reading of the mass of an atom because it is too difficult to determine their number and their mass, and also it is too difficult to work with such small number. For example, I show you. When I try to measure the mass of 1 grain of sugar, this cannot be detected by weighing machine because the mass is too small.
But Miss, I still want to measure 1 grain of sugar. Is there any other way that I can do?
Yes, don't worry, student. There is a way to measure it. Well, there is a way. Right, student? Therefore, it is easier to give each of atom a number on a scale and see how heavy they are compared to each other. So, how can we determine the mass of only 1 grain of sugar or mass of 1 atom? So, to encounter such this problem, chemists use the concept of relative atomic mass. What is relative atomic mass? Relative atomic mass is the average mass of an atom of the element compared to 1/12 of the mass of one carbon atom. Example, on the periodic table, we can see that the relative atomic mass of chlorine is 35.5. Basically, before this, chemists want to compare the mass of an element with hydrogen atom, and hydrogen atom acts as the standard atom. However, the usage of hydrogen atom as the standard encounter a lot of problems as the element is the lightest atom, and this will make hydrogen atom become difficult to compare with other elements. Furthermore, not many elements react with hydrogen. Finally, after many considerations, chemists choose carbon-12 as the standard because it is solid at room temperature, can be easily handled, and also carbon-12 can combine with other elements easily. Relative atomic mass of carbon-12 is exactly 12.0. Students, other than that, you also need to learn about relative molecular mass. Alright? Relative molecular mass is the average mass of the molecule when compared to 1/12 of the mass of one carbon-12 atom. For example, water molecule. One molecule of water is equal to 18 times the mass of 1/12 of carbon-12 atom. Hi student, now do you know how to differentiate between relative atomic mass and relative molecular mass? As for relative atomic mass, it is the sum of number of proton and neutron of an atom in periodic table. Meanwhile, for relative molecular mass, It is the sum of the atomic masses of all the atoms present in the molecule, and both are compared with 1/12 of the mass of one carbon-12 atom.
Oh, we understand, Miss. Is that all, Miss?
Not yet, student. We still have another part. For the next is relative formula mass. Relative formula mass is used for an ionic substance. Relative formula mass is quite similar with relative molecular mass, where we need to summing up the atomic masses of all the atoms in a molecule or formula unit. Do you get it, students? Yay! Good job! Now, let's see how to calculate relative molecular mass and relative formula mass.
Relative molecular mass can be calculated by adding up all the relative atomic mass of all atoms in the molecule. Let's calculate relative molecular mass for butane, which is assigned as C4H10. Based on the predictable, relative atomic mass for C or carbon is 12, and for hydrogen, the value is 1. So, the relative molecular mass for butane is 4 times relative atomic mass of carbon plus 10 times of relative atomic mass of oxygen, which are 4 times 12 plus 10 times 1 equal to 58. Now, as relative formula mass, you must remember, students, that relative formula mass is actually similar with relative molecular mass, but it involves ionic substance. So, just like before, you need to sum up all the values of relative atomic mass of all atoms in the ionic substance. As we can see, like copper to chloride, which is assigned as CuCl2. Now, look up on periodic table. Relative atomic mass for Cu is 29, and for Cl, the relative atomic mass is 35.5. So, the relative formula mass for copper to chloride is relative atomic mass of copper plus 2 times of relative atomic mass of chlorine equal to 100.
So, students, the most important part is you need to remember that relative atomic mass and relative molecular mass does not have unit. So, when you write the answer or show the calculation, make sure do not put the unit, yeah? From what I have explained before, do you get the knowledge, students? Okay, good. So, let's recap what you have learned for today, okay? So, in this lesson, you have learned the relative atomic mass of an element is the number of times the mass of one atom of an element is heavier than 1/12 of the mass of an atom of carbon-12. For relative atomic mass, the relative atomic mass of an atom of the element compared to 1/12 of the mass of a carbon-12 atom. As for relative molecular mass, the relative molecular mass of a molecule of the compound is compared to 1/12 of the mass of the carbon-12 atom. As for relative formula mass, we need to summing up the atomic masses of all the atoms in a molecule or formula unit. The reasons for using carbon-12 as a standard are: it is solid at room temperature, it is found in many substances, and easily handled. The average mass of each isotope is exactly 12 units. Here's an example of calculating relative molecular mass of a substance. The formula for relative atomic mass of an element is the number of times the mass of one atom of an element is heavier than 1/12 multiplied by one carbon-12 atom. Example, oxygen equal to 32. This means that one molecule of oxygen is 32 times heavier than 1/12 of one atom of carbon-12. Students, do you understand now what is relative atomic mass, relative molecular mass, and relative formula mass?
Yes, Miss.
Yay! Good job, students! You have done learn about subtopic 3.1. Let's meet in our future lesson. See you soon!
Now I understand about the concept of relative atomic mass and relative molecular mass, and I know how to calculate and measure it.